minutes is a lot. Okay, perfect. So we identify the degree, which is 6. Maximum possible number of turns. Max 5 turns. Perfect. Domain. Perfect. And behavior. Do we all agree with negative infinity to negative infinity? Because the leading coefficient is negative, x squared will be like this, and negative x squared will be like this. Always refer back to the simplest even degree function. Okay, perfect. So how many solutions will we find? 6, because the degree is 6. Perfect. So then negative 3x cubed and x minus 1 squared and x plus 3 is 0. I will divide both sides by negative 3 to make it as simple as possible. So then x cubed, x minus 1 squared, x plus 3 equals 0. And I'm sure you're going to give 6 solutions.
Zero 3 times, 1 twice, and negative 3 once.
Multiplicity for 0, Nate already told us. Multiplicity for 1 and multiplicity for negative 3. 2 plus 3 plus 1 is 6. Go back to the table. 0, 0. Multiplicity 3, what will that mean? Perfect. 1 comma 0, what will that mean? Multiplicity 2. Very good. And the last one, negative 3, 0. Very good. This looks a lot like the previous one. I should have chosen a different one, but sorry. Okay, ready? One, 2, 3, 0, 0, and 1. It's coming from negative infinity, crossing at negative 3, 0. From negative infinity, crossing at negative 3, 0. It has to turn because it has to come back and cross slowly at 0. Comes down to a negative number, but this minimum comes up to turn at 1 and then go down to negative infinity. Very similar. We'll see now if that maximum is as high as the other one was. Over 3,000. So let's go to y equals. Clear. And we have negative 3, x to the third. And then we have parentheses x minus 1 squared, and in parentheses x plus 3. Again, I'm going to attempt the standard zoom 6 and see what happens. It's coming from negative infinity, crosses at negative 3. Again, a whole story. It appears that that maximum is not that high as the other one was. So I'm going to go back to the viewing window and change the y maximum to 500. We'll see. Maybe it's more. Oh, okay. So with a scale of 1,000. Oh, I meant 100. Good. And graph again. So here it is. As a maximum, crossing, minimum, turn. So I see that the maximum is between negative 3 and 0. So I go to second and calc. Maximum is number 4. And no, I didn't want the right bound. I want again, sorry about that. 4, 4. So -3, 0, and enter. So we get -2.4 and 288.8. Again, I'm not asking you to, I'm asking you to find the min or max, but you don't have to go back and adjust the graph or try to find a proper scale. No, none of the above. We're just interested in understanding the function and being able to identify the pattern. Okay, now I want to determine this minimum, which is between 0 and 1. So I'll go to second and trace. And I want the minimum this time, which is 3. And I want between 0 and 1. And I don't want to guess, just give me the minimum. So 0.6, comma, -0.37. And that's it. Initially, oops, I'm sorry. Initially, I think these polynomials look scary, but when you come down to the details, once you determine the x-intercepts and the multiplicities and the end behavior, that's all you need, really. Any questions? Any questions on this? Okay, in the next section, I would like to refresh your memory on division of polynomials. So that's section 3.3, division of polynomials. And I want to remind you, please finish up everything for test 1, my math lab, everything by Sunday night. So we can say this is done and we're done with it. Please, everything by Sunday night. Is that okay? Okay. So what is the plan for test 2? So 3.3, 3.5, and 3.6. And then we will schedule test 2. Okay, so at the end of these 3 sections. If possible, I would like to have, we'll see if we can, maybe not, test 3 before Thanksgiving so we can review after, but it may not happen. So we'll see. So, but test 2, hopefully not this coming week, the next week. We'll see. Okay, so 3.3, division of polynomials. Division of polynomials. Here's one example that I did not find in your book. So if we're asked to divide a polynomial by a monomial, monomial means one term. For example, like x cubed plus 4x squared plus 3x minus 4 divided by x squared. This is one term, one monomial. There isn't really a way of dividing these two other than to separate the fraction into 1, 2, 3, 4. 1, 2, 3, 4 fractions and simplifying. That's all we can do. So this will be x to the third over x squared plus 4x squared over x squared plus 3x over x squared minus 4 over x squared. And if you say, what's this? You didn't do anything. You just separate. Yes, that is true. So it is a division. It is important for rational functions especially. And the only thing I can do is just simplify. I take 2 away from here with 2 from here, and I get x. I get 2 from here with 2 from here, and I get 4. I simplify 1 from the top and 1 from the bottom, so this is 3 over x, and then minus 4 over x squared. That's all I can do. I don't know why they don't present any problem like that in this section, but this is it. You don't have to do anything else. Now, if I'm asked to find or divide a polynomial divided by another polynomial, then there are 2 options. And the first option is the long division. That always works for anything except for this one. We do not ever use long division when we divide by one term. or a monomial. So I'm sure you remember the long division. If you don't, I will work with you on this anyway. Long division. So now there is another type of division, but this has limited applicability and only when the denominator is a binomial and it has to have degree 1. It must be a linear polynomial, degree 1. And this is called synthetic division. Can I use the long division in this case? Yes, I can. But this is specific for a synthetic division. Now, let me refresh your memory on a long division with examples, but I would like to show you, because you may ask, and it's a legitimate question. So let's say if I want to divide two numbers, you can say, grab your calculator. True, but I just want to show you something. Let's say 3925, and I divide by 15. So I'll say 15 goes into 39 twice. I go back and multiply 2 by 15, but I don't write 30. I write negative 30 because I have to subtract. And then I get 9, I bring down the next in line, and so on and so forth. So in case you're asking why 2 times 15 is 30 and I write negative 30, then you know why, because we have to subtract. This is the same algorithm for the long division. Nothing different, but it will look differently because it has x. We have x in polynomials, and we don't have x in numbers. So let's choose on page 392. Let's start with number 14. And we have x to the 4th plus 2x cubed minus 4x squared minus 5x minus 6, everything divided by x squared plus x minus 2. So we are asked to divide these two polynomials. Okay, fine. My first question to myself is, can I apply synthetic division? No, I can't, because the denominator is not a binomial linear degree 1, right? So this is something else. It's quadratic. So I cannot apply synthetic division. Good. So my only chance is long division. My next question to myself is, are these polynomials in descending order? Because if they're not, I have to rearrange them. Yes, they are. My last question before I start this algorithm is there a missing term from the top? Only from the top. I don't care if there is a missing term from the bottom. No, because the degree is 4. 4, degree 4 is there, degree 3 is there, degree 2 is there, degree 1 is there, degree, not power, degree 0 is there. So I can start this particular algorithm. Okay, so x to the 4th plus 2x cubed minus 4x squared minus 5x minus 6, and I'm dividing it by x squared plus x minus 2. Like before, I asked myself 15 goes into 39, and I put up here 2. I distributed and wrote the opposite. Okay, so my question is, x squared times what is x to the 4th? X squared times what is x to the 4th? Indeed, x squared. Now I have to be very careful because, again, it's the same algorithm, but it looks totally differently. Now I have to distribute x squared to all 3 terms. Change the sign from whatever to the opposite because we subtract. Every time I write underneath, and I have to write underneath each like term. I cannot put x cubed under negative 4x squared. I cannot put x squared under negative 5x. So let's distribute. X squared times x squared. But I have to write negative x to the fourth. X squared times x. It's x cubed, but I have to write negative x cubed. X squared times negative 2. So it's negative 2x squared, but I have to write plus 2x squared. And notice I wrote them one under the other as like terms. I draw a horizontal line. This will go away. And now I perform the operations I see, because I already took care of the signs. So 2x cubed minus x cubed. Perfect. Negative 4x squared plus 2x squared. I bring down the next in line. So here's my next question. X squared times what is x to the third? And at the top, I never lie. Sign? I cannot write x. I have to write a symbol. Perfect. Awesome. Great. So now let's distribute. X times x squared. But I have to write the opposite because I subtract. X times x. And I have to write the opposite because I subtract. And x times negative 2. Yes, but I have to write the opposite because I subtract. It's negative 2x, but I have to write the opposite. These two go away. What do I get now?
Negative 3x.
What do I get here? Awesome. And now I have to bring down the last in line. So final question now. X squared multiplied by what is negative 3x squared? And at the top, I don't lie. Very good. Awesome. Indeed, negative 3. So, negative 3 times x squared. Yes, sorry. Kayla?
In the blue chart, I thought, so when it says minus x squared from the negative 2x squared in the blue writing on the bottom, why isn't it plus x squared?
So x times x squared is x cubed. Change the sign. X times x is x squared. Change the sign. X times negative 2 is negative 2x. Change the sign. Only because, I know it's confusing a little bit, but only because, and I know 2 times 15 is not negative 30. But I have to change the sign because I subtract. And it's the same procedure, but I know it looks differently. So here's negative, and this is negative, and this is negative 6. So now we have negative 3 times x squared is negative 3x squared, and we change the sign to positive 3x squared. Negative 3 times x is negative 3x, change the sign to positive 3x. And negative 3 times negative 2 is positive 6, and change the sign to negative 6. I will box in the very last one. What does that mean? The remainder, and that's negative 12. So then I write the final answer. X to the fourth plus 2x cubed minus 4x squared minus 5x minus 6 over x squared plus x minus 2 is, I have to write the quotient plus the remainder over the divisor. So what is the quotient here? The quotient is x squared plus x minus 3. So x squared plus x minus 3 plus the remainder, yes, so negative 12 over x squared plus x minus 2. Yes, I can rearrange this and put a negative in front. So x squared plus x minus 3 minus 12 over x squared plus x minus 2. I want you to see this. I'm not going to put problems that are this long on a test because I'm not testing one topic. But you're going to see these problems in my math lab, so I just wanted to warn you. Any questions on this? Okay, so let's take a look at another one with long division, and that we can also apply synthetic division to. So where is it? Yeah, let's look at 4. So x cubed minus 2x squared minus 5x plus 6, everything divided by x minus 3. So here's the first question. Can we apply synthetic division to this problem? Yes, we can. And I will explain after we look at long division, we're going to apply the synthetic division to it. Okay. So are they both in descending order? Is there a missing term from the top? No. So just go ahead. X cubed minus 2x squared minus 5x plus 6 over x minus 3.
If there was a missing term, we just do like direct.
I will, yes, or just leave a blank, leave a space. That's fine. Yes. Either way. Whatever works. Good. So x times what is x cubed? Good. We go back and distribute. X squared times x. Yes, it's positive x cubed, but we write negative x cubed. And x squared times negative 3. But I have to write positive 3x squared. I perform the operations I see, which would give us an x squared. And I bring down negative 5x. X times what is x squared? And I need a symbol. Very good. So x times x, yes, and we change the sign. And x times negative 3, and we change the sign. So then what we get? Good. Final question now. How do I know it's final? Because the degree of this is 1 and the degree of this is 1. So it's definitely the final question. So what do we need to write at the top? So negative 2 times x, and we change. And negative 2 times negative 3 is positive 6, but change. So it happens that this particular division does not have a remainder. So then the answer would be x squared plus x minus 2. So here's a question I have for you. 9 divided by 3 is 3. And then I will say, since this number, 3, is a of 9. In that case, what can you say about x minus 3 for this polynomial? It's a factor because the remainder is 0. So then I will conclude then in the same way, x minus 3 is a factor of x cubed minus 2x squared minus 5x plus 6. So the long, say it again.
Do you want us to write that on the test?
It depends on whether the question is asking you to explain that. But so that's why the division of polynomials is very important, because it tells us which polynomial has which factors and if it has any. Okay?
Can we do one where it's missing?
Yes. Good point. Yes. So let's look at 27. Let's do this one with synthetic division, and then I'll come back and, yes, perfect. So the same problem with synthetic division. So x cubed minus 2x squared minus 5x plus 6 divided by x minus 3. First thing I have to identify is a. Remember, I compare this to x minus a. So then what is a? 3. What if I have x plus 7 and I compare it to x minus a? Exactly what we did with the circle and so on and so forth. So what will be a in this case? Negative 7. Agreed? So here a is indeed 3. So the algorithm for synthetic division is, in this tiny box, we have to put a, which is 3. Next to the box to the right, I will have to copy only the coefficients of the polynomial. If this is missing, I will have to put 0 for it. So 1, -2, -5, and 6. A horizontal line, leave some room, and here is the syntax or the algorithm for this. When we apply synthetic division, the first step is we have to copy the leading coefficient. 3 gets multiplied by 1, and the answer gets written under the next coefficient in line. So 3 times 1 is 3. We perform the operations we see. 3 minus 2, or -2 plus 3, is 1. I continue in the same way. 3 multiplied by 1 is 3, and I write it under the next coefficient. I perform the operations I see. -5 plus 3 is? Final step, 3 times -2. -6. And here's the box. What do I put in the box? Indeed. So now, how do I know to read the answer? Here's how I do it. What is the degree of the top?
3.
If I divide by the degree of the bottom, which is, what degree do I get? So then this is the coefficient of which term? X squared. And this is the coefficient of? And this is the free term. So that's how we write the answer. So can anyone dictate? X squared plus x minus 2. And this is exactly what we got, no matter what method we use. Any questions? And I know I will not forget to pick 27, in which some terms are missing, and you will choose the method. It can be both. It can be long division. It can be synthetic division. So 27 is x to the 5th plus x to the 3rd minus 2 divided by x minus 1. Okay. Which method would you like to apply? Long division or synthetic division? It happens they both work. Long division? Very good. Perfect. So let's apply long division. Are both polynomials in descending order? Perfect. Is there any missing term from the top?
Yes.
Yes. So x to the 5th is there, but the next term is missing, so leave some room. The next one is x to the 3rd. The next one is missing, so it's positive. So the next one is missing, which is power 2. The next one is missing, which is power 1. And then the last one is -2. Now, what happens if I don't leave those spaces? Well, I will not be able to properly divide. What if I leave the spaces and I don't use them? That's okay. If I don't use them, I don't use them. So, first question, x times what is x to the 5th? Perfect. I go back and distribute. X to the 4th times x. I have to write the opposite. X to the 4th times -1. Negative x to the 4th, but I have to write x to the 4th. Where will I write it? Right here. So positive x to the 4th. So these two go away, but I have to write x to the 4th again and bring down x to the 3rd. X times what is x to the 4th? Very good. And the sign? Positive x to the 3rd. X to the 3rd times x. Subtract. X to the 3rd times -1. So it's negative x to the 3rd, change. Are you surprised that I ran out of room? No, because I always run out of room. So these two go away. So this is 2x to the 3rd. And this is later on -2. X times what is 2x to the 3rd? Symbol? Very good. Notice that these have to decrease in power. If you all of a sudden you write x to the third, something is wrong, right? So x to the fourth to x to the third to x squared. There may be some skips. It's possible, but you cannot go higher. Okay. 2x squared times x. 2x cubed and subtract. 2x squared times negative 1. Negative 2x squared plus 2x squared. Bring down 2x squared. And later on negative 2. Next question. X times what is 2x squared? Symbol? Good. 2x times x. So I have to subtract. Very good. Plus 2x. So then 2x minus 2. Finally, x times what is 2x? Symbol? Good. 2 times x is 2x, I subtract. And 2 times negative 1 is negative 2, and I subtract. Way too long, but I couldn't find anything else. So the answer is all this. About remainder, what can you say about the remainder? 0. Okay. So now I'm asking you, what if we have an error here? How will I check? Exactly. I will multiply this by x minus 1. What should the answer be? The top. If it isn't, this is wrong. Yes, the same one? Yes. Very good. So let's do that. That will be much easier. What goes in the box? 1. Very good. So let's find the coefficients. 1 is for power 5. What will it have for power 4? What will have for power 3? What will have for power 2? What we have for power 1, or degree 1 if you want, and what we have as the free term. 1, 2, 3, 4, 5, 6. For degree 5, 6 terms. Yes? Very good. So it comes from the denominator. So if x minus 3 is in denominator, then we have 3. If we have x minus 1, we have 1. If we have x plus 5, we have negative 5. Good. So I bring down the first coefficient. Always the leading coefficient gets copied. Now, 1 times 1. We copy 1 up here. We perform the operations we see. So it's 1. 1 times 1. So then 1 times 1 is 1. We add 1. 1 times 1. 1. 1 plus 1. 2. 1 times 2. 0 plus 2. 1 times 2. 0 plus 2. 1 times 2. Box in. Good. So the top had degree. The top has degree 5. The bottom has degree 1. So then the quotient has to start with which degree? 4. So then the answer will be x to the 4th. If you want, but that's not necessary. I don't recommend it. I'm just making a point. But this is not necessary. But if we had a remainder, it would have been whatever over x minus 1. What can you say about x minus 1 for this polynomial? Yes, it's a factor. It's a factor. Because the remainder is 0, that is a factor. Any questions about division of polynomials? Yes, please, Kayla, go ahead.
On the test, will we have to do both of these, like both types of
Yes, but not on a page and a half like I had it here. No, no, no. I'm not testing endurance. I'm testing understanding. No, no. No. So this will be very useful for section 3.5, and you will see. In section 3.5, there are 3 different types of rational functions.